In previous class, we covered the basics of Go. We looked at variables, data types like string, integer, and simple functions. We also got familiarized with Go syntax and structures. In this class, we'll go in deep on control structures in Go, and then we'll go one by one. Alright, let's start with control structures. Go has few essential structures for controlling the flow of our program, using if statements, switch statements, and loops. Starting with if statement, this case, let's start with the if statement in Go. You don't need parentheses around conditions. For example, here is a simple if else block that checks if a number is positive, negative, or 0. You can relate this with Java or C++. We will be using the parentheses where here it's no need. Let's look on to the switch statements. Switch in Go don't require a break for after each case. So after each case, the break is not required, which is different from some other languages. Here is an example. You can also add a fall through to let the execution continue to the next case. Though it's not a very common thing, feel free to experiment that. Next, go on to for loops. Now, Go has only one looping structure, the for loop, but it's versatile. Here is a traditional loop that prints number from 0 to 9. And you can also write an infinite loop with for if you want, like this below. And finally, there is a for range loop, which is great for looping over collections like slices and maps. This is super useful for working with data in Go. We'll see that in later cases. Great. Next, let's talk about some composite data types, arrays, slices, and maps. Arrays in Go is a fixed size collection of elements, all of the same type. Here is an example. We declare like var array of 5 integer. So that's going to contain integer of arrays. So this is how we declare it. Arrays are a bit rigid because you have to define their size upfront. Let's go on to slices, which are more flexible. Slices are essentially view into an array, but can grow dynamically. You can create slices with a literal or with the make function. This creates a slice with length of 3 and a capacity of 5. You can use functions like append to add elements to a slice, which makes them very practical. Let's go on to maps. Finally we have maps, which are key value collections. Maps are a bit like dictionaries in other languages. Here is how you create a map in Go. With map, you can add, update, or delete key value pairs. Maps are really useful when you need to look up value by case. Let's move on to functions. Now let's look deeper into functions. Go has some interesting features like multiple return values, named return values, and periodic functions. First, let's see about multiple return functions. Go functions can return more than one value, which is super helpful for handling results and errors at the same time. Here is an example. So this divide function in the Go performs division on two integers a and b, and is designed to handle cases where the divisor b is 0, which would otherwise cause a runtime error. A and b are input parameters of type int. That's what we are declaring it here, responding the numbers to be divided. And then we are declaring int and error specifies that the function returns two values. and int is the value. It is going to be it will divide a b and return the successful one. And if any error, it will return that as a error type. Inside the function, checking for division by 0, it checks if b equal to 0, it will return the 0. It will directly throws division by 0. The function checks if b is 0, and then as I said, it will throw the error. Performing the divisor. If b is 0, if b is not 0, this is the other case, the function performs the division a divided by b. If it returns the result of the division as return value. Nil is returned as the second value, indicating no error occurred. In Go, nil is often used to signify the absence of an error. We keep using this in many places. Next, let's go on to the named return value. In Go, you can also name your return values. This can make your code more readable in certain cases. Here is how we do. This add function demonstrates the named return value in Go. Result int is declared as a return value when defining the function. This means result is automatically available as variable inside the function using the named return value. Here, result in this one, the assigned the sum of a and b, because result is already named the function signature. You don't need to declare it with any colon equal to or variable. Return. Since result is already defined, just writing return automatically returns the value of the result. In short, with named return values, you don't need to specify the return variable in return. This can make the code cleaner and more readable. Let's see about variadic functions. In this code, function sum of nums of int defines a variadic function, which means it can take a number of arguments. Here's a simplified breakdown. It can take variable number of arguments. So we'll discuss that. Nums of int means you can pass in any number of int arguments to sum, like for example sum 1, 2, 3 or sum 10, 20, 30, 40. Inside the function, we have total is 0. We are setting up the starting value of the total. The for underscore and num range nums loops go through each number in nums and add it to the total. Finally, it will return the total, gives back the sum of all numbers. So if you call like sum of 1, 2, 3, it returns 6. And if you call sum of 10, 20, 30, it returns 60. The variadic parameter here, nums of int, let you pass as many integers as you like to be added. Okay, let's see about the basic error handling. In Go, errors are typically returned as the last value in function and are handled explicitly. This is different from some other languages that use exceptions. Here is the basic example for a function that returns an error. And if you, this is the basic thing, you can understand errors.new and print the error. And if you want to format your error message, you can use this format.errorf. This covers the day 2 of Golang. We'll see with some other detailed concept in the upcoming class. Thank you.